Hi, Math 1 students. This is Mr. Dobner wishing you a Happy New Year and a welcome back to school. We are in our very first section of Mod 4, and we're going to do some Ready, Set, Go notes. So here's our 4.1 Part 1 lesson here. We've got an expression. An expression is a mathematical representation made using numbers, variables, and symbols. So an example of that could be something such as 2 times x minus 5 plus 4. So we've written many expressions in the past, and we've just done that as we've been working with our 4.1 task. Let's go through something very similar to the task right now. And letter A, the description of this action, it says the number of students that bought pizzas. So we'd have X. Well, it says after the second week for B here, the number of students that bought pizzas increased by 10. So, of course, what we're going to do is we'll have the number of students that we had before, that's X, but the increase by 10 is going to tell us that will have a plus 10. That's all we have to do. For part C, it says after the third week, the number of students who bought pizzas tripled. So the number of students who bought pizzas tripled. Tripling means that you're multiplying by 3. So you'd have 3 times what you had previously. And we saw that previously we'd have this x plus 10. Then finally, for D, it says in week 4, the number of students who bought pizzas decreased by 9. And as we're looking at this decrease, of course, we think about going down. That indicates subtraction, minusing a 9. And what you're going to see is we're going to have that previous amount that we had just come up with. That was in week 3. Now in week 4, that amount is going to have a subtraction of 9, a decrease by 9. So very similar to what we've been doing in our first task, and a very important skill, being able to go between a verbal expression and converting that into an algebraic expression. So as we're going to really get into quite a bit of simplifying, we're going to see that we can apply properties of operations such as distributing, and that's one of 3 simplifying strategies. We can also combine like terms, and finally we can have dividing. So we're going to look at distributing first, and as we look at distributing will always involve multiplication. Multiplication over addition or subtraction. So 3 gets multiplied first to this x. Then we'll say minus, and 3 times 4 is going to leave us with a 12. We have just distributed. As we take a look at another way that we can simplify, that's going to be combining like terms. As we're looking here, we can see that this expression has 4 different terms to it. The 4x minus 7 and the 5x plus 2. 2 of these terms have x's in them. And 2 of these terms actually don't have a variable whatsoever. So the 4x and the 5x, we always look out in front to see if a term is positive or negative. The 4x doesn't have a positive or a negative in front. It's assumed to be positive. So this is a 4x plus a 5x. That just becomes 9x. Then we're going to look at our minus 7 and a plus 2. Negative 7 plus 2 is going to be negative 5. So we could leave our answer simply as 9x minus 5. Taking a look at dividing, we're going to see quite a few expressions involving fractions. And if you look at your numerator, you're going to see that you actually have two distinct terms in the top, a 15x and also a minus 20. And there's only one denominator, and that's a 5. This involves division. More specifically, what it's saying is the first term in the numerator, 15x, is being divided by 5. And we also have this 20, the second term. It's also being divided by 5. Both of those terms up on top are being divided by 5. And we can separate that into two distinct terms and then simplify. 15 divided by 5 we know is 3. That's a 3x. 20 divided by 5 is just a 4. So we'll have 3x minus a 4. So again, we're going to have these three fundamentals: distributing, combining like terms, and dividing. And just as we had done in our previous module, where we were working with showing equivalence, we're going to do this once again. We're going to determine if two expressions are equivalent, and we're going to have to show work. We must show work to justify our reasoning. To earn credit, you can never just simply circle yes or no. You have to show your step-by-step breakdown. So this 13 right here, I do want to point out that this is really like a 13 with a minus 1 out in front. And the reason why I'm looking at that minus 1 is because that's what is being distributed. You can distribute that negative. Negative 1 times a 2a, you get a minus 2a. Negative 1 times a minus 5, well, that's going to turn into a plus 5. And at this point, I hope you notice, once we've distributed, we can also, in this case, see if we could combine like terms. We're using two of these skills right now. And 13 plus 5, they're both positive. They add up to 18. And then, of course, you'd have an 18 minus 2a. What you have here are the same expressions. So we're going to say, yes, that is indeed true, that they are equivalent. Let's take a look at this second term right here, the second problem, I should say. 24b minus 12 all over 2. This certainly looks like the division problem that we had looked at earlier. We have two terms in the numerator. We may write two separate terms divided by 2. And 24 divided by 2, of course, is a 12. This would become a 12b. 12 divided by 2 is simply a minus 6. Then what? Well, over here, this 3 and the 4b minus 12, we can distribute. 3 multiplied to 4b is going to leave us with a 12b. And then 3 times 2 is a 6, and we have this 12b minus 6. You can see as you've both used division and you've distributed for these separate expressions that they simplify to the same thing, and that means they are indeed equivalent. Well, for our last problems, thank goodness we have some friendly review right here, and we're going to jump on in and take a look at graphing once again. The first problem here, y equals 1/2 and this x minus 4, y minus 7, looks very much like what we had for our point slope form of a line, and indeed it is. You probably have seen more of these equations written backwards. You can write it either way, of course. But I do want to point out that a lot of times we'd have that first y value, and I could write it up here just as well, y equaled y1 plus m times x minus x1. And of course, as we'd set up a table, this style would be a little bit more apparent from how we would write things out in a table. Hopefully you remember doing this. We didn't do it all that long ago. We're always going to be looking for a starting point, and we're also going to be looking for the slope. And the slope, I hope you can quickly see, is going to be 1/2. That's the number in front of the parentheses. It's going to tell us to go up 1 and go right 2. But our starting point, you might remember that this x minus 4 is going to relate to the opposite sign of this x. You see that minus 4, it actually will be a positive 4, and then our y coordinate is this minus 7. So again, just something to point out for you, a friendly reminder. You'd have your starting x1, y1, but notice how it's written in the parentheses. It's not x plus x sub 1, it's x minus x sub 1 there. So, that's just coming into play, that we have that changing of the sign. So we could graph this very quickly. We can say, well, I will go to the point 4, negative 7, and here's a 1, 2, 3, 4, and we'll see down here's 1, 2, 3, 4, 5, 6, 7. So we're right here at 4 comma negative 7. But our slope is telling us to go up 1 and go right 2, and go up 1 and go right 2, and go up 1 and go right 2. Could also go down 1 and go left 2. We could definitely do that. Do that again, down 1, left 2. Do that maybe one more time, down 1, left 2, just to really stretch that out. And then you can nicely see what this line is going to look like. As we finish, you're going to see that y equals negative 3x plus 6 for our final problem looks very much like y equals mx plus b, or y equals b plus mx, as we could also write it. This is your slope y-intercept. And, this is where, of course, we'd have a starting point of 0 comma b. And, of course, our slope is just going to be m. So, as we're looking here, y equals negative 3x plus 6, whether you want to write that in this other form, it really doesn't matter. I hope you can see quickly that your starting point is going to be the point 0 comma 6. Here is your b, and your slope, well, yeah, it's mx, so we're going to have negative 3, or negative 3 over 1. That indicates we'll go down 3 and we'll go 1 to the right. So 0 comma 6, well, we'll be at 1, 2, 3, 4, 5, 6. That's right up here. And then we'll go down 3, 1, 2, 3 steps, 1 to the right. And we'll keep doing that. Go down 3, go 1 to the right. And you could continue to do that. And very quickly you will see that you are forming a line. You could also go up 3 steps and go 1 to the left. And it won't take you too long to get this line graphed. Hopefully that's a friendly reminder for you. And that's it for our 4.1 Part 1 Ready, Set, Go notes.